Hi, so I'd just like to talk to you about what we've been up to with ACCESS-NRI and how it fits in with CMIP7 plans. And this is the work of quite a large team, and I particularly like to acknowledge the great efforts of Mikhail, Doogie, Elil, Anton and Minghang, without whom none of this would have been possible. So for CMIP7, there's a development plan. You've seen this diagram a few times already, and just for context, those top two are the CMIP6 submissions we had, and so ACCESS ESM 1.5 and ACCESS CM2, and ACCESS CM2 has MOM5 and SICE5, which is actually ACCESS OM2 as its ocean and sea ice components. So for CMIP7, we've got a kind of a two-pronged approach. There's ESM 1.6, which is an incremental upgrade to 1.5 with an improved land surface and ocean biogeochemistry and ocean configuration. But that's for Thilo's talk later in this session, so you'll find out more then. The part I'm talking about is this other part, which is basically all new model components and coupler. So it's ACCESS OM3, which is the ocean and sea ice part, CM3, which is the physical climate model, and ESM3, which is CM3 plus BGC. So ACCESS OM2 is the current workhorse we've got in COSIMA. As I said, it's the ocean sea ice part of ACCESS CM2 and ACCESS CM2 025, and it uses MOM5 and SICE5. And we've had a big community grow up around this model. And in the last 5 years, over 80 papers have come out on the back of it, so there's a lot of momentum behind it. But it's built on these model components, which are now kind of at the end of their lives. They're not really being developed internationally anymore. So we actually do need to sort of keep up to date with what's going on internationally. So that's what ACCESS OM3 does. So it upgrades to MOM6 and SICE6, and optionally adds WaveWatch 3 as a surface wave model. So all of these components are at the forefront of international development, and MOM6 has a new arbitrary Lagrangian Eulerian vertical coordinate, which basically means you can choose any coordinate you like, and it can be time dependent, and it has much improved numerical properties, so much less spurious diapical mixing. It doesn't have a vertical CFL constraint, so the layers can actually be vanishingly thin, and better grid. It allows circulation in cavities under the ice shelves. Better support for regional domains. It allows you to do wetting and drying, so ice sheets can retreat, or you can have shoreline change with the model. Better representation of tides, and a longer time step is possible for traces, which makes it possible to carry a large number of traces, such as in a biogeochemical model. SICE6 has a distribution of sea ice flow sizes as well as thicknesses in the model, and a representation of the landfast ice and better biogeochemistry. And WaveWatch 3 is a state-of-the-art surface wave model, which can be coupled to the other components. So diagrammatically, this is the Antarctic margin. We've got, in ACCESS OM2, we weren't able to represent the cavities under ice shelves, and so the edge of the model was basically the edge of the carving line, the front of the ice shelves. But with this new vertical coordinate, we can explicitly represent the cavity circulation. And Claire Young's been doing some amazing work on the numerics of this to do it as accurately as possible. As I said, SICE6 has a landfast ice and flow size distribution. The WaveWatch surface wave model, it can break up the sea ice to affect the flow size distribution, and it was also damped by the ice as it propagates into it, and can also mix the surface ocean, and the ocean can refract the waves as well. So there's two-way coupling between these components. And there's more on this on Anton and Elil's posters. So we've got a whole suite of configurations we're aiming to develop within COSIMA, and so they're at a range of different resolutions, and we're starting off at the low resolution end to get the basics bedded down, like getting the coupling working properly, but we're moving towards a 10th degree and higher, maybe 0.04 degrees is an ultimate kind of aim here. And there's, in terms of what's included, it could be ocean and sea ice only, or include biogeochemistry, which is the wombat component, or include surface waves as well. And a number of these are already at the technically running stage, but being tuned and improved. There's a subset of these that are relevant to CM3 and ESM3, which are those two. So those configurations at a quarter degree are intended for CMIP7. So the architecture looks like this. We've adopted a new coupler technology called NUOPSI, which is extremely flexible and powerful and opens up a lot of possibilities in the future for coupling other things such as ice sheets. And so in ACCESS-OM3, we've got size 6, MOM6, WaveWatch 3. WaveWatch 3 is optional, and there's prescribed atmosphere and runoff going into the model. There's a 1 degree configuration running, including with the surface waves and also with the biogeochemistry, and a quarter degree is also running and has been tuned to be as fast and cheap as ACCESS-OM2 at a quarter degree, which we're quite pleased with. But as I said, we're working towards higher resolution. For CM3 and ESM3, basically those prescribed forcings get replaced by the UK Met Office UM13 GAL9 atmosphere, and the plan is to use the Cable 4 land surface model, which is under development at the moment. So our test configuration is running at 1 degree, and this is the work of Martin Dix and Kieran Ricardo, and that's using joules at this stage. And but the aim is for a quarter degree for CMIP7. And Kieran's got a talk tomorrow in the ESM working group about that. So there's a lot of configurations, there's a lot of interrelated development. We've got these sort of green lines in this diagram of different development sort of branches and configurations. And we've got a coordinated development process where we can have improvements in one of these branches being fed into the others to try and keep everything coordinated. So that's for the ACCESS-OM3 suite and for the ESM and CM suite. But it's also been plumbed into the upstream versions, so we're actually drawing in from the very latest developments internationally as they arrive. So just to show you what that looks like, this is a schematic with the fields coupled between the 3 model components in a MOM6 size 6 WaveWatch 3 simulation. And this is what it looks like. So this is the work of Valil and several collaborators. And so the top left there is showing the significant wave height, and there's a green line there which is the 15% sea ice concentration contour. So as the waves penetrate into that sea ice zone, their amplitude is damping down, and it's actually damping right down to single precision 0, so we're getting these nans on this log scale, so don't be distracted by that. The main thing is that the waves are being affected by the sea ice concentration. And the top right is showing the flow size distribution, and that is also being modified by the waves coming in and breaking up the sea ice. And a little poster has more on that. For the biogeochemistry, the biogeochemical model that's currently in ACCESS EM 1.5 looks like this. It's very simple in the world stage. There's 2 nutrients, 1 phytoplankton, 1 zooplankton, and 1 detritus, and a constant Redfield ratio. And Doogie has re-implemented this in a way which enables it to be put into MOM6. But there's been a lot of work being done, led by Piers Buchanan, to upgrade this. So this is a multi-step process, and the first step is Wombat Light, which he will talk about tomorrow, I think. And this it basically improves the ion cycle, has better representation of chlorophyll and variable stoichiometry in these various BGC components. And there's also work underway towards Wombat Mid, which takes advantage of MOM6 being able to carry a large number of traces. So this is going from 14 to 30 traces, which should be tractable with a longer tracer time step. So this now has multiple types of phytoplankton and zooplankton and detritus and multiple nutrients and representation of far more of the biogeochemistry. So I'll just leave it there, but basically this is a quick overview to show that this coordinated development of ACCESS-OM3, CM3 and ESM3 and it opens up a lot of new avenues for research in the years to come.
Sorry, I might have missed it in your slide, but are there plans to have both the wave model and the BGC up and running in the higher resolution OM3 runs?
That depends on how well we can get the wave model scaling. We're not intending to have the wave model running at the same resolution as the ocean, because it has bad parallel scaling properties, basically. So the notion there would be to be holding that to some course of resolution, but then coupling it to a finer ocean. To some extent, it depends on community demand as to how much interest there is in getting something like that up and running. But yeah, technically it will be possible, but it's a matter of choosing priorities. Yeah. Sorry.
The BGC?
BGC at high resolution, I don't see a reason why not. Yeah.
You might have answered this in the answer to the previous question, but what do you see as the biggest barrier to getting the OM3 up and running, and what is your strategy for dealing with it?
Oh, it's like an interview question. These things all take time, so it's. I don't see any big barriers to getting it working, but it's an incremental process of ironing out glitches and wrinkles and bugs and things at lower resolutions and working up. What it will take is some close collaboration with the scientific community to have people look at test runs, check out the results, let us know if there's things that upset them, and basically the more input we can have from the scientists who might want to use this model, the more useful we can make the model for the scientific community. So it can be quite a symbiotic thing if we get the communication happening and people involved.
One last question over there.
Hi, Andrew. Just wondering if you can comment more about the Antarctic bottom water formation in these new versions and how different it is from the previous ones.
So at the moment, we've only had it running at 1 degree and a quarter degree, and I haven't actually looked at the bottom water formation. I'm not expecting it to be good because it wasn't very good at OM2 at those resolutions. We're hoping to have it at least as realistic at 1/10 degree with this new configuration, but we won't really know until we try. And we've got some ideas, but it's a little bit mysterious still as to why it is so good in OM2 at 1/10 degree. So hopefully we can still get that, and maybe something even better. Yeah, it's certainly it's a figure of merit that we're aiming to have. Yeah.